A very good morning to one and all present here. The first session is on probability and its applications for researchers by Dr. D. Arivudainambi, Professor, Department of Mathematics, Anna University. Sir is recently awarded with the TANSA Award, Tamil Nadu State Council for Science and Technology by Department of Higher Education Award. He was recently awarded. We are glad, sir, and we congratulate you, sir. A brief introduction about the speaker. Sir did his BSc in Mathematics from Arinyar Anna Government Arts College, University of Madras, and MSc in Mathematics from Presidency College, Chennai, University of Madras. And he's also done his MCA in Computer Science from Annamalai University. His research degrees include MPhil in Operations Research from Faculty of Mathematics, Loyola College, Chennai, PhD in Stochastic Processes and its Applications from Faculty of Science and Humanities, College of Engineering, Guindy, Anna University, and postdoctoral research in Computer Networks, University of Toronto, Canada. His areas of specialization include computer networks, queuing theory, stochastic processes and its applications, operations research, cloud computing, wireless sensor networks, evolutionary algorithms, ad hoc networks. He's also guided many research scholars and he's also published many papers. We are happy to have you with us, sir. I now invite our Director, Madam, Dr. C. Umarani, Madam, Center for Research, to felicitate Professor. Kindly accept it, sir, as a token of our love and appreciation. Thank you, sir. Over to you, sir.
Yeah, good morning. I thank Director Research and the team for inviting this forum. Yeah, of course, though I am from Maths department, I don't take much on Maths. In fact, I don't know much Maths. In fact, so see that what will be the takeaway after this session. That's very important. Yeah, of course, why this topic is any research paper when we publish, of course, they are expecting at least one math equation, right? So IEEE, ACM, Springer and all, they're expecting at least one math equation. And we, of course, at the end of the paper, when we write any case study or numerical work, at the end we prove that what we have done. That's what the agenda today. So, of course, this topic has been very important and people will be talking about for the next 20 years. This is going to play a major role, AI in machine learning. So, in that scenario, so as well as research, I'm going to talk about this. Be relaxed, be comfortable, okay? Just whatever you like, you just kirikana podum notebook la. No formalities, nothing. Kirikitting na, that's more than enough, okay? So, of course, this is the topic. Is it clear? Is it clear? Okay, right. Right. So, I would like to introduce first this word, right? I would like to, when we use this word, okay, likely, maybe, choosing, when we use these words in our day-to-day life, just leave research. When we use these words, is it tough to answer this question? When we are not sure, come on. When we are not sure, then what else? Okay. Decisions, okay. When we use these words, of course, can you live without using these words in a day? Can you talk to anyone without using these words in your life? In at least a day? At least a day without using these words? Maybe, likely, choosing. Can you live like this without using these words? Not possible, okay? Why we are using this? My question is this. Why we are using this? Okay. 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 Then what else? Is it tough question? Is it tough question first of all? You like to repeat in Tamil? If it's, my English is very poor. ஏன் யூஸ் பண்ணணும், எதுக்கு யூஸ் பண்ணணும், ஏன் யூஸ் பண்ணாமல் லைஃப் போகாதுன்னு சொல்கிறோம்? choices, okay. Yeah, uncertainty, whenever we are not sure, right? So we know all the possibilities, okay. Okay, so we are sure it may happen, it may not, when there is uncertainty. Now my question is, it is not sure, it is uncertain, still we are using this why? Got my question now? It is uncertain, it may happen, it is not sure, still we are using these words why? What is the lesson? Oh. Say I can say, I may join for lunch, instead I will join for lunch. I am not joining for lunch. Why we are using I may join for a lunch? Simply we can say, நான் வரேன் வரல வந்தாலும் வருவேன் ஏன் ஏன் okay 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 so that's our research, right? Is it that's our research, right? Our research is almost uncertain. Okay, it is uncertain. Okay, we focus on one thing, we end up on the other thing. Okay, paper எழுதும்போது வேறவா இருக்கும் முடிக்கும்போது வேறயா இருக்கும், right? So because this plays a major role when we talk about data science and AI. Okay, so let's define this word first, probability. Just recollect what we studied in our 9th standard. I hope you remember this letter. I hope you remember this. Sample space. What is sample space? See, this is not only to mass. எல்லாரும் படிச்சிருக்கோம், எல்லாரும் யூஸ் பண்ண போறோம் ரிசர்ச் பேப்பர்ல. At least you have to write at least 2 lines of mathematical equation in your paper. That's the assignment given to me. Okay, that is assignment given to me today. Okay, you have to write at least, see, you take any ACM transaction, IEEE transaction, Springer of more than 3 impact factor, see to that, of course, there will be 2 mass equation in between. Whether they are using at the end, that's different arena. But they will be writing, right? That's the assignment given to me, right? So sample space. What is sample space? All possible cases. Let's say I'm tossing a coin. Okay, this is my sample space. When I throw a dice, okay, this is my sample space. When we talk about this auditorium, what is a sample space? What is a sample space? Is it 1 to 60? 60 members, right? 60 or? Yeah. Yeah, it's a sample space. So sample space is nothing but set of all possible cases. என்னெல்லாம் இருக்கும், நடக்கும், நடக்காது, இருக்கு, இல்ல. All possible cases we talk about a sample space. Okay, so sample space. So let's say A is subset of S. A is a subset of S. இந்த சிம்பிள்லாம் பார்த்தாம இருக்கா, ஞாபகம் இருக்கா? இல்லைனாலும் பரவாயில்ல, nothing wrong in it. It is subset, part of it. This row is my subset. We have 4 rows. This is my subset. Okay, so let's say A is H. A is H. Subset, part. This first row is my subset. Okay, let's say electrical people who are sitting here is my subset. Electronics people who are sitting here is my subset. Okay, subset of S. Part of it. Our intention is to define this word. Can we define this? Probability of A. Probability to get A. Probability to get H. I'm tossing a coin. As you said, we are not sure whether we get head or tail. We are not sure, right? So, what is the probability to get hit? Probability to get hit. It is simply n of A by n of S. Number of elements in A divided by number of elements in S. Number of elements in A divided by number of elements in S. Okay, see to that this is 1 by 2. What is my numerator? Number of favorable cases. எனக்கு என்ன வேணும், எனக்கு என்ன தேவை, எனக்கு என்ன பிடிக்கும், அதுதான் என்னோட numerator. What I'm expecting, what I need, what is my focus, that's my numerator. The denominator is all possible cases. All possible cases. Is it so? Is it so? Let's say this case, my sample space is, let's say 1, 3, 5. What is my probability to get either one of this? What is this? Is it 3 by 6? Now the question is, can we define any of our real life problem as a probability? That's the question. Okay? Any research work, anything which falls under uncertainty, can we define like this? What are the conditions should be satisfied to define this? That's very important, right? When I can define this word probability. To use this word, right? The first condition is, this should be between 0 and 1. See that here, we'll be getting 1 by 2. See again, okay. Let's say B is 5 and 6. So what is probability of B? It is 2 by 6. See to that, the value lies between 0 and 1. When we get 0, any example, when we get 0. See here, we'll be getting 1 by 2, 1 by 3. Okay, the value lies between 0 and 1. 0 and 1. The question is, it can't be negative, it can't be more than 1. I could see many of the theses and even research papers, especially when I get IEEE Springer and all, I'll see anywhere they use Springer, the probability. I'll search. And whether they have the relevant result is between 0 and 1. That's what I do. Initial step. Okay, anywhere they use whether probability, the word probability. And see that I'll check whether the values are between 0 and 1. If they wrote somewhere 1 point or 2 point, the evaluation is very simple. Immediately, initial screening itself, I'll say this paper is not suitable for this journal. That's it. Because the researcher doesn't know what is probability. That's the conclusion. Okay, so the value lies between 0 and 1. So when we get 0, when it is impossible event, nadakave nadakadu, possibility illa, chance illa. Anything, solunga paapom, which is not possible, impossible event? Impossible, chance illa. We use, right? Every day we use at least once. Chance illa, seyyave maata, mudiyave mudiyadu. Either to wife or wife to husband, or to the kids, or kids to parents, or students to teacher, teacher to students. It's impossible, chance illa. Anything? Any example? Okay, great. What else? Sun rises in the west. Sun rises in the west. It's impossible. Without writing a research paper, completing a thesis, especially Anna University, it's an impossible event. Okay, without journals, will it be possible to submit a thesis? It's an impossible event, right? So when it is impossible, we get 0. When we get 1, it is sure event. Nadande thirum, senje mudipen. Any example? Okay. Sun rises in the east. Sure event. Okay. So the value lies between 0 and 1. That's very important. It can't be negative and it can't be more than 1. Suppose you are getting something like this, it is not a probability. Got it? Suppose you are using any software or calculator. Suppose you are getting like this, that's good. That's good. 0.999 is good, but 1.001 is not acceptable in the case of probability. Okay, so This is what the first condition it should be satisfied. And the second condition is when you add all the possibilities, you have to get 1. When you add all the possibilities, you have to get 1. When you add all the possibilities, you have to get 1. Sum of the probability equal to 1. It is otherwise called as normalization condition. We use this in research often. Normalization condition. Okay. Let's see here. Our B is tail. Yeah. Yeah. Probability of B is again 1 by 2. Probability of A is 1 by 2. When you add this, you will get 1. Sum of the probability equal to 1. Let's say this row contains 20. Then choosing this 1% from this is 20 by 60. Then plus this, plus this, plus this. When you add all the possibilities, you have to get 1. That is otherwise called as normalization condition. Normalization condition. Sum of the probability. When you add all the possibilities, you have to get 1. Okay. So, and the third condition is, of course, very important. Of course, very important. This is very, very important condition. This is P of A plus P of B. School la padichala nyabam varudha? Varliya? Especially old like me. Kandipa nyabam irukum. Chinna vayasula irukavanga marandirupinga nenikiren. Right? Because the teacher taught like that. Okay. P of A plus P of B minus P of A intersection B. Temporarily, I am putting that as 0. Temporarily, I am putting 0. For that, I am giving a condition. If A and B are mutually exclusive, when A and B are mutually exclusive. Again, see, lecture will be interactive, okay, so that I will learn much from you. Can you define exclusive? No definition, just example. Exclusive. Exclusive. Whether my questions are very tough or it's basic. What is exclusive? Exclusive? Okay. See, anything when we purchase, even a water bottle, first thing what we do, whether it is inclusive of VAT or exclusive of VAT. GST, exclusive of GST or inclusive of GST. So what is exclusive? I hope, yeah. So yesterday also we got a news around 3 o'clock stating that exclusive news. What do they mean by exclusive news yesterday? Exclusive. What do they mean by exclusive? Unexpected is exclusive. Okay, to create the attention, is it exclusive? Exclusive. Excluding, it's nothing but excluding, right? Exclusive. What do you mean by exclusive? Exclusive. Okay. Gaza war, right? That's exclusive event. See, there will be a difference in the news, right? Sometimes they call as breaking news, sometimes they call as exclusive news. Okay, yeah. So maybe you might have read magazine like Kumudamar Anandavidan. They write here exclusive interview with actor Vijay. Exclusive interview with actor Vijay. What they mean by exclusive interview with actor Vijay? Coming. It is not published elsewhere. They are the one they are publishing first time. Of course, when you go through it inside, what will be inside? எனக்கு பிடிச்ச திரிஷா எனக்கு பிடிச்ச பாட்டு நான் அடிச்சா தாங்க மாட்டேன் தூங்க மாட்டேன் something will be like this. But what they mean by exclusive, it is not exposed to the outside world. They are the one they are exposing first time. That is exclusive. They are the one they are exposing the content to the outside world first time. Then come to mutual. What is mutual? Mutual, we have a lot of example for mutual. Mutual funds. Okay, mutual funds, right? Mutual funds. What is mutual fund? What is mutual fund? கடைசியாக முடிப்பாங்கல்ல மியூச்சுவல் ஃபண்டில் நமக்கு புரியாத மாதிரி சில வார்த்தைகள். Subject to market risk. Why they call as mutual fund? Why they call as mutual fund? We invest money, they invest somewhere else. If they get profit will be share. If it is loss, no share. That we have to bear. Company பொறுப்பல்ல அவ்வளவுதான். So mutual. Okay. So now tell me what is mutually exclusive. We know what is exclusive. But we know what is mutual. What is mutually exclusive? Mutually exclusive. I hope you are all good in English. No, same. Apro. Good. That's right. Mutually exclusive. Okay. Okay. Mutually exclusive. Both are independent? Yeah, of course. Unique? Yes, of course. Mutually exclusive. Why I am going in depth is, of course, we are using this in our research papers. We are using this. Can you, some electrical and electronics computer science people, can you write any paper without using the word random? Can you write a research paper without randomness in your electrical, electronics, computer science? Of course, except math department, everybody is using this. So, mutually exclusive. Can we say like this? Let's say. Mutually exclusive is completely different from independent. Independent is different, mutually exclusive is different. Let's say I'm tossing a coin. First time I'm getting hit. Second time I'm tossing the same coin. I may get hit. See the word, I may get hit or I may get tail. The first time hit will not influence in any way getting hit again or tail. That's mutually exclusive. புரியாத மாதிரி சொல்லிட்டேனா? ஃபர்ஸ்ட் டைம் ஹெட் வருது, செகண்ட் டைம் ஹெட் வரலாம், டெயில் வரலாம். இந்த ஹெட் வர்றது எந்த வகையிலையும் இன்ஃப்ளூயன்ஸ் பண்ணக்கூடாது, ஹெட் வர்றதுக்கோ டெயில் வர்றதுக்கோ. அப்படி இருக்கிறத தான் நம்ம மியூச்சுவலி எக்ஸ்க்ளூசிவ் அப்படிங்கிறோம். ஸோ see the mutual is different, exclusive is different. Okay, let's say there was a rain today. Yesterday, there is a rain. What is the probability to get rain today? நேத்திக்கு பொழிஞ்ச மழை இன்னைக்கு எந்த வகையிலையும் இன்ஃப்ளூயன்ஸே பண்ணக்கூடாது. இன்ஃப்ளூயன்ஸ் பண்ணிச்சுன்னா என்ன பண்ணக்கூடாது? ப்ராபபிலிட்டியை யூஸ் பண்ணக்கூடாது. இன்ஃப்ளூயன்ஸ் பண்ணிச்சுன்னா ப்ராபபிலிட்டியை யூஸ் பண்ணக்கூடாது. Let's say there is an accident in a road. There is a machine failure. That first machine failure should not influence in any way for the next machine failure or forthcoming machine failure. எந்த வகையிலும் இன்ஃப்ளூயன்ஸ் பண்ணக்கூடாது. ஏதோ ஒரு ஈவெண்ட் நடந்திருக்கு, அந்த நடந்த ஈவெண்ட் நடக்க போற ஈவெண்ட்டை எந்த வகையிலும் என்ன பண்ணக்கூடாது? இன்ஃப்ளூயன்ஸ் பண்ணக்கூடாது. அப்படி இருக்கிறது தான் we call as mutually exclusive. Okay, that mutually, that's why we are putting here 0. Of course, we use this later. Okay, so it is mutually exclusive. The events are mutually exclusive. If that is the case, then only we can use this probability. So when you like to use this word, in your paper, or when you like to use probably I will join, see to that these conditions are satisfied or not. If these conditions are not satisfied, please avoid using this word probability. And of course, we should be very cautious when we use probability of happening this is 7, 3, 2 like that. It shows that we are insufficient knowledge in our domain. Even in your thesis or in your research paper, you even use probability, the word probability, see to that the value should be between 0 and 1. If you write 2, 3, of course, last week also I read a very leading newspaper in economics. They wrote the probability of happening is 70. What they missed there? 70%. If it is 70%, that's fine. If they write 70, that's absurd. Okay, so at least when we use this word, we should check whether it is between 0 and 1. Right. Okay, so these are all we studied in our school. The next part is, I hope you are all convenient in this. I hope you remember this. I hope you remember this. Suppose this is A, this is B, and this is what? A intersection B. We call this diagram as what? Yeah, vanilla diagram, exactly. Is it vanilla? Yeah. So this is what? Our A union B. Right. So what else we studied in our school? Suppose this is A, and what is this? Of course, yeah. This is A complement or A dash. So why we need this? Why we need this? P of A plus P of A complement equal to 1. Sum of the probability should be equal to 1. Suppose your P of A complement is, that is, success equal to 1 minus of failure. Success equal to 1 minus of failure. Or similarly, failure equal to 1 minus of success. Let's say I'm saying that group. I'm splitting this into 4. Okay, this is my A complement and remaining is my A. Okay, success plus failure equal to 1. Okay, so I'll stop here from the school studies. Let's go to the next level. Of course, the research level. Maybe those who studied electronics, electrical, mechanical, civil, you might have know this. What is this? A given B. Probability of A given B. A given B. Given B. B is given to us. We need to find the probability of A. That means that B is already happened. A is going to happen. நடந்து முடிஞ்ச ஒரு விஷயத்தை வச்சுக்கிட்டு நடக்க போற விஷயத்தை கண்டுபிடிக்கிறது. Got it? One is already happened. One is already happened. The other one is going to happen. Conditional probability. See to that here also, when we type in Microsoft Word, you will be end up like this. When you type in Microsoft Word, when you type like this, if you ஒரு ஸ்பேஸ் பார் கொடுத்தோன்னே இந்த மாதிரி வந்து நிற்கும். ஒரு ஸ்பேஸ் பார் கொடுத்தோன்னே இப்படி வந்து நிற்கும். தீசிஸ்ல என்ன இருக்கும்? இதே தான் இருக்கும். So there is no such word in probability. That should be avoided while writing a research paper and in your thesis. Okay, there is no such things. A probability of A divided by B. Of course, when you type this, if you use space bar, you will end up like this, and it will be printed in the thesis like this. That will be considered as a major mistake. Okay, so there is no such thing in probability, right? So A, conditional B, conditional B, conditional B. With the condition of B, we are going to find this. This has a lot of applications in our day-to-day life, and most of the time we are using in our research papers. India won the match against Afghanistan yesterday. It's over. What is the probability to win A? What is the probability to win against New Zealand? Is the next match is with New Zealand? What is the probability to win against New Zealand? If I know what is common between A and B, I'll predict whether India will win or not. If the players are same, of course, who is not there for the next match? Next match. மேட்சே பார்க்கறதுலையோ எல்லாம் படிக்கிறவங்களோ? யார் இல்லை நெக்ஸ்ட் மேட்ச்க்கு? ஹர்திக் இல்லை. ஓகே, ஸோ சேம் பிச் கண்டிஷனான்னு தெரியணும். ஆப்பனண்ட்டும் அதே மாதிரி இருக்காங்களான்னு தெரியணும். வெதர் இட் இஸ் நெதர்லாண்ட் ஆர் ஸ்ரீலங்கா ஆர் ஆப்கானிஸ்தானான்னு பார்க்கணும். ஆப்பனண்ட் யாரு? வேற லெவல். ஓகே, so if we know this, and of course who's winning the toss, that's also very important. First batting yaru, that also plays a major role. And of course rain. Okay, if we know that, we can predict whether India will win or not. I'll say few examples which has been implemented in the industry and it is very successful. And those who are doing research relevant to media, maybe it's useful. Those who are above 40 like me, you know this example. Maybe kids 20, 25, you don't know this advertisement. You know, there is advertisement 20 years back. Do you remember this? Sunday na rendu. Can you remember that advertisement? Those who are above 40. Sunday na rendu. Iவ்வளவுதான் advertisement இருக்கும். Can you remember this advertisement? Sunday na rendu. No? சின்ன பசங்களாம் தெரியாது. I told you already. Kids, you don't know. Those above 40, you might have seen this advertisement. Sunday na rendu. இந்த மெட்ரோ பிரியான்னு ஒருத்தங்க வந்து பேசிட்டே இருப்பாங்கல்ல, அந்த சேனல்லாம் பார்த்துருக்கீங்களா? ஓகே, சண்டே na rendu. Can you remember this advertisement? Nearly a month. மேபி நான் ஆன்சர் சொன்னா எஸ் அப்படின்னுவீங்க. above 40 இருக்கவங்க. Yeah, you are right. So you are not 40, right? Oh, then how do you know this? Sorry? Oh, okay, great. There is advertisement. Sunday na rendu. Nearly a month. அப்படியே ஒரு கிரேஸா இருக்கும். என்ன பண்ண போறாங்க? சண்டே na rendu. ரெண்டு தடவை சாப்பிட போறோமா? ரெண்டு தடவை தூங்க போறோமா? What's going to happen? That's what the advertisement. Very graceful advertisement. Sunday na rendu. அவ்வளவுதான். முடிஞ்சிடும். ஒரு நிமிஷம். அப்பெல்லாம் ஏதோ ஒரு நிமிஷத்துக்கு 10 லட்சம் சார்ஜ் பண்ணுவாங்க மீடியால. சண்டே na rendu. அவ்வளவுதான். One fine morning they said Sunday na தினமலர் வந்து நமது மலர்னு ஒரு காம்ப்ளிமெண்டரி கொடுத்தாங்க. அதுதான் நடந்துச்சு. நமது மலர்னு ஒரு காம்ப்ளிமெண்டரி. That's it. That advertisement is very famous in Tamil Nadu and the circulation is become higher for தினமலர் later. Now they are saying தமிழில் நாங்களும் நம்பர் 1ங்கறாங்க. நாங்கள் மட்டுமே இல்ல, நாங்களும் நம்பர் 1ங்கறாங்க. Am I right? They are saying நாங்களும் நம்பர் 1. That advertisement. Okay, so they haven't said what's that. Okay, அதுக்கப்புறம் அந்த பேப்பர் இப்ப கூட நம்ம ஊர் பக்கம் போனோம்னா அப்படி ஏதோ கோயில்ல வெள்ளிக்கிழமை கூழ் ஊத்திருப்பாங்க, சனிக்கிழமை பொங்கல் செஞ்சிருப்பாங்க. அதுதான் அந்த நமது மலர்ல வரும். Local news, like that's what Sunday na rendu. That's what they said. The circulation has become very high for that particular journal that time. I hope those இந்த 30 வயசு கீழ இருக்கவங்க இந்த அட்வர்டைஸ்மென்ட் பார்த்திருப்பீங்க. தெரியலன்னு சொல்ல விடாது. Okay? Yeah. அர்ஜுன் அம்மா யாரு? Can you remember this advertisement? ஆரோக்கிய மில்க். அர்ஜுன் அம்மா யாரு? அர்ஜுன் அம்மா யாரு? அவ்வளவுதான். They just copied the formula what Dinamalar did. What Dinamalar did, they did here. அர்ஜுன் அம்மா யாரு? அவ்வளவுதான். அதுக்கப்புறம் தான் 4.5% பால் அப்படி இப்படிலாம் மில்க்ல வேரியேஷன்லாம் அப்புறம் தான் வந்துச்சு. அதுக்கு முன்னாடி ஒரே பால் ஆவின் தான். Right, now the question is, one is the media newspaper, the other one is the milk product. What is the relevant here, A and B? Can you relate A and B now? One is the paper, the other one is the milk product. Why they have chosen this method? Marketing, of course. Yeah, so this paper base become very popular in Tamil Nadu. The same technology, the same media thing they used. Daily use, of course, daily use. What else? வாட் எல்ஸ்? பேப்பருக்கும் மில்க்குக்கும் என்ன ரிலேஷன்? பேப்பருக்கும் மில்க்குக்கும் என்ன ரிலேஷன்? யாராவது கேட்டிருப்பாங்களா இந்த கேள்வியை? காலையில் that's it, it's useful for one day, in the evening it is next day waste. Of course we have very big bureaus in nowadays in our home. There is no such bureau in our home 20 years back. I hope you will. இந்த பீரோங்கிறத எதை சொல்றேன்னு ஞாபகம் இருக்குன்னு நினைக்கிறேன். ஆமாம், பீரோவில் இப்போ டிவிலாம் வந்துருச்சு. பீரோவில் டிவி வந்துருச்சு, வைஃபை வந்துருச்சு. என்னது அது? ரெஃப்ரிஜிரேட்டர். Refrigerator is like a bureau size nowadays. We are kept everything keeping in the fridge nowadays. Those time there is no fridge. காலையில் பால் வாங்கிட்டு ஹீட் பண்ணி ஈவினிங் ஹீட் பண்ணி மீதி இருந்தால் தயிராக இருக்கும் next day morning. The newspaper is also like that. It will be useful for a day. Next day it's a waste product. So it is, so the relevance. See, those who are in media, that time, the best, largest selling newspaper in Tamil is, that time 20 years back, Dinatandi. Dinatandi is quite familiar at that time. Why Dinatandi is quite familiar? Why Dinatandi is quite familiar? Lot of content, and it is colloquial. கன்னித்தீவு அஃப்கோர்ஸ். அப்புறம் சிட்டுக்குருவியார் ஆந்தையாரா? சிட்டுக்குருவியார் பாடுகிறார். வாட் எல்ஸ்? வாட் இஸ் த யூட்டிலிட்டி ஆஃப் தினத்தந்தி? மேபி இஃப் இட் இஸ் நாட் ரெக்கார்டட், I'll tell you so many things. Since it is recorded. What is the utility of தினத்தந்தி? Okay. Gossips. Okay. So importance to the local news. காலையில் பார்த்தோம்னா ஹெட் நியூஸே என்ன போட்டிருப்பாங்கன்னா, அந்த வெளில தொங்க விட்டுருப்பாங்கல்ல, தொழிலதிபர் கொலை அப்படின்னு இருக்கும். நம்ம பார்த்தோம்னு வச்சுக்கேன், யாரா அது அப்படின்னு. திருநெல்வேலி பக்கத்தில் குற்றாலம் பக்கத்தில் டீ கடை வச்சிருந்தவரை கொண்டுட்டாங்க அப்படின்னு எழுதியிருப்பாங்க. ஸோ they give much importance to the local news. Similarly, the milk product, ஆவினஸ், மில்க்குனாலே ஆவி நம்மலாம் தெரியல, இந்த above 40 இருக்கவங்கலாம் இப்போ கூட பான்ஸ் எடுத்துட்டு வாங்குவோம். பான்ஸ்னா என்ன நம்மளை பொறுத்தவரைல? பவுடர். ரின் எடுத்துட்டு வா அப்படின்னா துணி சோப்பு எடுத்துட்டு வான்னு. இப்போ இருக்க பசங்களாம் டிட்டர்ஜென்ட் கேக், பாத்திங் சோப், ஓகே, ஷாம்பு. நாங்கெல்லாம் ஒன்லி சிக் அப்படின்னா எப்படி பசங்க எப்படி பா, என்ன சிக்கு? சிக்குன்னா எங்களை பொறுத்தவரைக்கும் ஷாம்பு. லைபாய் எடுத்துட்டு வான்னா சோப்பு, குளிக்கிற சோப்பு எடுத்துட்டு வா. above 40. ஓகே, ஸோ தட் டைம், ஸோ ஆவின்னாலே மில்க், பேப்பர்னா தினத்தந்தி. So that kind. So that advertisement broke that. Of course, தினத்தந்தி மாதிரி நம்ம யூட்டிலிட்டியை பார்த்தோம்னா, maybe of course we are very health conscious. ஆனால் 4 மணிக்கு நம்ம அந்த பக்கம் டீ கடை பக்கம் போயிட்டோம்னா அந்த பஜ்ஜி சாப்பிடாம நம்மளால இருக்கவே முடியாது. எந்த டாக்டர் என்ன சொன்னாலும் சரி. ஏன்? அது ரோட் கடையில் பஜ்ஜி தான். வீட்டில் சாப்பிட்டா பஜ்ஜி சாப்பிட்ற ஃபீலே இருக்காது. இட் இஸ் எ கேக் சாப்பிட்ற ஃபீல் இருக்கும். ஏன்? ஆயில் நல்லா இருக்காது, டஸ்ட் வரணும், அப்பதான் அதில் டேஸ்ட் வரும். அதர்வைஸ் யூ டோன்ட் கெட் டேஸ்ட், ரைட்? ஆயிலோட டெம்பரேச்சர் அதிகமாக இருக்கணும். வீட்டில் அவ்வளோ ஆயிலில் வச்சு ஹீட் பண்ண முடியாது. ஆயில் வந்து ஹீட் ரொம்ப இருக்கணும். அஃப்கோர்ஸ் தட்ஸ் அ டிஃபரன்ஸ் பிட்வீன் ஆம்லெட்ல ரிசர்ச் எடுக்கலாம்ல. வீட்டில் போடுற ஆம்லெட் கடையில் போடுற ஆம்லெட்டோட நல்லா தானே இருக்கு. கடையிலன்னா ரோட் கடையில் you have the same omelette in very big hotel, you don't get such feeling. Even Baroda, right? Why we are getting very good Baroda on the roadside than a hotel or home? The temperature, right? It's a chemical reaction, of course. Temperature. அந்த பிளேட்டை நம்ம அளவுக்கு அந்த அளவுக்கு ஹீட் பண்ண முடியாது நம்மளால வீட்டில். அந்த திக்னஸ் இருக்கணும். Of course, Baroda as நம்ம வீட்டில் அப்படியே ரொம்ப டிசிப்ளின்டா ஆயில்லாம் போடுவோம். கடையில் நம்ம எதை பெருக்க யூஸ் பண்ணுறோமோ அதை வச்சு இப்படி தடைவா. அஃப்கோர்ஸ் எனக்கு கனடாவில் ஒரு ஸ்டூடெண்ட் இருந்தான். சார், இந்தியன்ஸ் ஆர் வெரி worse சார். when they make பரோட்டா in Malaysia, they use these things for chemical reaction அப்படின்வான். ஓ மை, yeah, of course. பார்த்துருக்கீங்களா இல்லையா? that's also required for பரோட்டா, right? so தினத்தந்தி, so of course for the bhaji making everything, ஈவினிங் அதில் வச்சா தான் என்ன ஆகும்? நீங்கள் வேணால் ஹிந்து பேப்பர்லையோ டிஷ்யூ பேப்பர்லையோ வச்சு பஜ்ஜி சாப்பிட்டு பாருங்க, நல்லா இருக்குமா? டிஷ்யூ பேப்பரில் என்ன ஆச்சா என்ன ஆகும்? மொத்தத்தையும் உறிஞ்சிரும். ஹிந்து பேப்பரில் வச்சா உரியவே உரியாது. தினத்தந்தியில் வச்சா நமக்கு தேவையான டேஸ்ட்டில் கரெக்டாக இருக்கும். I hope I am right, the person from media. Okay, so A conditional B. So the strong, the media use that because the same thing one day useful and we cannot keep it more than one day and it is strong. Avin அப்படிங்கிறதுனால milk அப்படின்னு ஒரு ப்ராடக்டை வச்சு தான் இந்த மாதிரி. This kind of advertisement is very famous. I hope those who are traveling in the Chennai roads, you can see such advertisement now. Have you seen one kind of advertisement like this? It reaches immediately to the people mind. இப்போ ஒரு advertisement வந்திருக்கு, உடைச்சு பார்க்கலாமா? Can you imagine what is advertisement? யோசிக்கிறோமா இல்லையா? என்ன உடைச்சு பார்க்கலாமா? ஏதா பஸ் ஐயா உடைச்சு பார்க்கலாமா? So such kind of advertisement is quite familiar in the media industry because when it is useful is if they are very strong enough in that area to reach the people mindset immediately. They use this. This is, so see here, it happens to Dinamalar, why not to the milk product? We have the same things. One is already happened. One is already happened. It is happened to Dinamalar, why not for us? Because the product is same. So this is what the industry uses this. Even any tea product, you can see, if it is a tea product, it will be launched in the north of India. If the tea is good enough, if the sales is high, they launch that product in south of India. If it is not popular there, either they try to change the flavor, the cost, something like that. If it doesn't familiar there, they stop the product there itself. Similarly, if it is a coffee product, they launch first in south of India. You can't get such product in north. If you say a coffee powder, maybe, I don't want to say the brand name. Yeah, so if it is a coffee product, they launch here. If it is successful here, they launch in north of India. It is success in south of India. One is already happened, then they do it. You know the Tata Magic, there is a car, right? We call it as colloquially Kutiyana, right? It was quite familiar in north more than 2 years. Then only it came to south of India. Okay, it is successful there, they are using here in marketing. Maybe, yeah, of course, I was part of this in a research forum. See, first passenger car for Tata. First passenger car for Tata. Can you read? Indiga. It is iconic symbol for us because iconic symbol are the ambassador alichadu adha. Why it is? We concerned about more mileage, zero maintenance. We never bothered about comfort, safety. Okay, mileage and maintenance. Then it is the sales of that Indiga, they increase the boot space. Colloquially we call boot space as what? Boot space can என்ன சொல்லுவோம் ஊர்ல இல்லையா? Boot space என்ன சொல்லுவீங்க? Boot space is nothing but the luggage we keep in the car, in the back side of the car. Yeah, dicky. They just increase the boot space. They kept same engine, same interior, everything they kept as such. They increase only the boot space. They called it as Indigo. Indigo. It is also very quite familiar. The same thing it was used almost in all the car industries. They either increase the boot space or they reduce the boot space. Can you say cars such things? Increase the boot space? Swift, exactly. That's what I'm expecting. Swift and Swift Desire. First it was Swift because it is happened to Tata. Why not for us? It is already happened. See to that, in these cases, it is not necessary for them to do a big market research, or it is not necessary for them to establish 10,000 crores project. It is simple, conducting simple marketing survey from the people, they can simply decide this. Because Tata, it is happened to Tata, the same Indian mentality, same Indian condition, so we'll increase. Can you say some cars, boot space korcha karla? Etios will become Etios Leva. Tiago. Ford Fiesta became Figo. Ford Fiesta தான் என்னாச்சு Figo ஆச்சு. So இதுதான். So it happened to Tata, to Maruti. Why not for us? That's it. Conditional, with the condition. It is already existing. Why not for us? It is called conditional probability. Can you imagine some example in our research we do like this? Especially civil and mechanical. Civil and mechanical. One is already happened, the other one is going to happen. Of course, real life, of course, no doubt. Real life, of course, no doubt. ஏன் PhD பண்றோம்? Those who did, they became faculty in Ananist IIT. Why not for us? Okay, right? So, of course, research, of course, right? So, one is, there is a success for them. We are adopting the same thing. Of course, we all realized, just for a lighter note, okay, sari vanda. Okay, so one is already happened, the other one is going to happen. நடந்து முடிஞ்ச ஒரு விஷயத்தை வச்சுட்டு நடக்க போற விஷயத்தை கேட்குறது. இதுதான் conditional probability. Otherwise, you might have used this in your maybe research or in your ME program. This is called multiplication rule. Multiplication rule. Okay, with the known, finding the unknown. With the known, finding the unknown. See to that again this follows under this class. This falls under this class. Right. Yeah, so this is again now. So what? I know this probability. I know my conditional probability. So what? What I'm going to do with this? Let's see next agenda, right? So this is a very big topic. I'll condense it. I'll try to complete before 11. Okay. It requires at least 3 hours of time. Maybe we'll see later. Bore அடிச்சா சொல்லுங்க. What is variable? It is not fixed. It is not deterministic. It is not constant. It varies. Can you say some examples for variable? Climate, weather condition here, temperature here. How about our memory? It is a variable only. It's not fixed. How about the speed of this fan? How about the light? Whether it's fixed 40, they say 60 watts, whether it is 60 watts? No, not always. The flow, air conditioner flow, they'll say 23 degrees. Is it so always 23 degrees? It's all random. The speed of a vehicle, it's random. Okay, so it is variable. So what is random variable? Random variable. I'm expecting you have to explore the meaning exactly, then only you can use in your research. Exact meaning, in whatever may be the area you like, or in real life, random variable. Example, I'm not expecting any, not in order, yeah? Yes, sure. Random variable. Sudden change. Predicted. இதான் எக்ஸாம்பிள் சொல்ல முடியுமா? லைஃப்ல, ரியல் லைஃப்ல, இல்ல மெஷினரியில. Any example? Heartbeat, okay? Then articles published, particles, okay? Temperature, yeah, temperature. How about men? You are going home around 9:30. Okay, you are knocking at the door at 9:30. What is the response? Can you predict what will happen? Yeah, of course you can predict what will happen. You know what will happen that particular day? Of course you'll get dosa, no doubt. Oh, sorry. Just for fun I'm making this, for a lighter note. It is a random variable. It's not fixed. Number of accidents in a road, temperature here. These are all just random variable, right? So this random variable just இப்ப மட்டும் கொஞ்சம் focus பண்ணுங்க. இதுதான் நம்ம subject உள்ள போறோம். Now only we are going into the subject. We define the random variable in two types. I hope I'm right. Discrete and continuous. You have studied in your undergraduate BE these things. Just we are seeing only the application. You have studied in your BE. Discrete and continuous. Just don't bother about the definitions, what we are going to discuss here. Just bother about the application, what we discuss here. Discrete. Number of participants not turned up today. Number of machine failures. Number of accidents in a road. Number of machine failures. Number of employees not turned up for a day. Let's say like this, 10, 100, 1000, 10,000, 1 lakh, like this. If it is countable, we call it as discrete. The continuous, the other one, the continuous is, I travel between 30 to 60 kilometer speed. How many numbers are in between this? 30 to 60. The random variable x takes 30 to 60. How many numbers? That's what I'm expecting. 30, 32? 32? 31. How many? Infinite. Between 30 to 60, we travel between 30 to 60 kilometers. Always we are traveling 30 or 60. How many numbers? 30.1, 30.11, 30.112, 30.2, 30.3, 30.31, 31 again, 31.2, 32.2, something like this. So we have infinite numbers. See to that. See, that's what, right? Very simple. When we talk about internet speed, whatever may be the leading brand, they say, sir, you will get up to 80 Mbps, sir. Is it? Whether they said you will get 80 Mbps? Whether they said you will get 4 Mbps? They never said you will get 2 Mbps. They'll say up to 2 Mbps you will get. Whether it is 4G or 5G or leased line, they'll say up to 8 Mbps. Why they are using 8 Mbps? What they mean by that? What they mean by up to 8 Mbps? சமயத்துல 0 கிடைக்காம கூட போய்டும் அப்படிங்கறத இன்டைரக்ட்டா சொல்லுவாங்க. That's what they mean. Up to 8 Mbps. That is 2 Mbps, 3 Mbps. Sometimes you don't get, sometimes you will get 128 kbps also. That's what. So it is between this temperature here. Can you say what is the temperature here? We can say 35 to 40 degrees or 30 to 40 degrees. That's what. Is it always 30? No. Okay. Can you differentiate what is discrete and continuous now? Can you differentiate what is discrete and continuous? When we say by number 20, 30, 40, 50, 100, 1000, 1 lakh like this, it is discrete. Number of accidents in a road, number of employees turned up for a day, number of employees not turned up for a day, number of mistakes in the thesis, number of papers published, like this. It is countable, discrete. When it is like this, temperature, I travel between 30 to 60 kilometer speed, and air conditioner flow, and in fact electrical voltage, you say always 240, whether you will be getting always 240? No. We get sometimes 0 also, even 120. That's why we will be keeping stabilizer, right? What stabilizer does? It boosts and குறைக்கிறதுக்கு என்ன சொல்லுவீங்க? ஆமா, boost converter, buck converter எல்லாம் யூஸ் பண்ணுவீங்களே எலக்ட்ரிக்கல்ல. You know, I know these words. Okay, boost and buck converter and all electrical people use, right, lot? Am I right? Okay. So electrical தொட்டாலே ஷாக் அடிக்கும், கரெக்ட்டா? I'll tell you why later. Okay, so discrete and continuous. When it is discrete, we call as probability mass function. See, while writing research paper or thesis, you should be very cautious, very cautious. When you use discrete, you call it as PMF, and when it is continuous, you have to use the word PDF, probability density function. For discrete random variable, if you write probability density function, it will be a wrong. See to that. When it is discrete, we call it as probability mass function. When it is continuous, we call it as probability density function. Of course, whatever we discussed here, it should be between 0 and 1. And when it is discrete, okay, sum of the probability equal to 1. ஏன் இன்டெக்ரல் நடத்துனாங்கன்னு தெரியுதா ஸ்கூல்ல? அப்ப தெரியாது, இந்த மேக்ஸ் வாத்தியாருங்களே வேஸ்ட் அப்பா. எனக்கும் பிஇக்கும் சம்பந்தமே இல்லை, இன்ஜினியரிங்க்கும். Why they are teaching like this? See, when it is 30 to 60, right, it is continuous. I can say 0 to 24 degrees, 0 to 1500 RPM. That's what fan, right? Normal fan, standard fan, it is 0 to 1500 RPM. 0 to 8 Mbps speed. When we call in number 20, 30, 40 and all, we'll be using discrete. We call as probability mass function. Here we call as probability density function. Here only we'll be using this integral. Got it? So what? What I'm going to use it for my research. Okay. So we can find expected value of x. Expected value of x. Otherwise it is called as mean mu. I hope you had the same class yesterday. Mean, is it? Mean is taken yesterday? As an expert professor, he is very good in research. Professor Pierre Mohammed, right? He has taken yesterday. I learned a lot from him. Expected value. See that yesterday you used the word mean or average. The same thing we are calling as expected value of x. Even you can write in your thesis as mean or average, nothing wrong in it. If you use the word expected value, that gives a different flavor. Expected value. Why we are using the word expected value in probability? Why we are using? In the case of statistics, we'll have a data. We'll have a data. In the case of probability, ஒண்ணுமே இருக்காது. That's research. Not research, industrial research I'm talking about. ஒண்ணுமே இருக்காது. When we talk about probability, we call it as, கிராமத்தில் கலோக்கிலா சொல்லுவாங்கல்ல, ஒன்றும் இல்லாமலே பயங்கரமா பேசுறான்னு என்ன சொல்லுவாங்க? வெறுங்கையில் முழம் போடுறது, வெறுங்கையில் முழம் போடுறது அப்படின்னு. So we don't have data, or with the partial data we'll make a conclusion. Without data or with the partial data will be. That's why it is called as expected value. What is expected value? See to that, before laying a road, if this road breadth is this and these many cars are passing through this, how many accidents will happen? If these many accidents will happen, these many ambulances are required, these many doctors are required. This will be predicted using probability. எப்ப? ரோடு போறதுக்கு முன்னாடியே. ஸ்டாட்டிஸ்டிக்ஸ்ல என்ன நடக்கும்? ரோடு போட்டு வண்டி போய் ஆக்சிடென்ட் ஆகி அதுக்கப்புறம் பேசுறது எது பெஸ்ட்? ரோடு போறது முன்னாடியே டிசைட் பண்றது. That's why the people will be talking about AI and machine. This plays a major role before laying. See, that's what that's why we're using the word expected value of x, expected value. Instead of mean, in probability we use expected value of x, expected value of x. Okay, and in the case of continuous, x into f of x into dx. Don't bother about this math because we have software, Minitab, MATLAB, SPSS. We have software. Don't bother about the math involved. Just know this. Why I'm writing here is, when you write expected value in your thesis, just add this also. One math equation is there. Okay, you write on an average like this. Okay, so expected value, right? And this is otherwise called as first moment. Maybe you discussed yesterday also, first moment. And if this is first moment, this is second moment. And this is second moment. So why I need this? I can find variance. Variance is nothing but second moment minus First moment the whole square. Don't bother about the math involved. We have software. Okay. What is the use of variance? We can find standard deviation, square root of variance. Yesterday also you discussed the same thing. There you had a data. Here we don't have any data, or with the partial data we'll make a conclusion. If you are making any decision based on the past papers, what they have done, and these results are there, I am comparing that, that comes under statistics. That comes under statistics. Okay, it's a very simple example, probability, very simple example. Car manufacture பண்ணவே கிடையாது. Manufacture plant ஆரம்பிக்கல. Before manufacturing itself, they should have an idea of how many cars will be sold out. If these many cars are sold out, how many cars will become requires repair? If these many cars are repaired, how many service centers are required? If these many service centers are required, how many spares are required? How many service personnel are required? This should be decided when? Before manufacturing a car. If the same thing reverse, think like this. Manufactured car, service ku vandachu, adukaprom service பண்றதெல்லாம் பார்க்கலாமா? எவ்வளவு நாள் ஆகும்? It takes at least to establish a service center, at least requires a 6 months of time. அப்ப என்ன ஆகும்? காரை பத்தி general opinion. There is no proper service, that car is failure அப்படிங்கிற mentality. So with the data when we play it, it is statistics. With the partial data, like conditional probability, if it happens to some company, why not for us like this? Then we make that decision, that is probability. See, we haven't done anything, not manufactured a car, still we can find out what will the standard deviation, how many cars will be repaired, how many service centers are required, how many service personnel are required, how much the spare is required. This is the way we make probability. That's the difference. ரொம்ப சிம்பிள். ப்ராபபிலிட்டி பற்றி பேசும்போது எப்போ கடவுள்கிட்ட போவோம்? ப்ராபபிலிட்டிக்கு நல்ல எக்ஸாம்பிளாக முடியும். எப்போ கடவுள்கிட்ட போவோம்? ஐம் நாட் சேயிங் பர்டிகுலர். எப்போ கடவுள்கிட்ட போவோம்? ஓகே ஓகே, கேன் யூ ரீகலெக்ட் எப்பெல்லாம் கடவுள்கிட்ட போயிருக்கோம்? எக்ஸாம் முன்னாடி. ஒய் 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 இன்னைக்கு போயிருக்க மாட்டோம். யாரோ பேச போறாங்க, நம்ம லிசன் பண்ண போறோம். தேங்க்யூ. அஃப்கோர்ஸ் பிஃபோர் பிஹெச்டி இன்டர்வியூ மைட் ஹவ் கான், ரைட்? எக்ஸாம் முன்னாடி போறோம். எக்ஸாம் முடிஞ்சதுக்கு அப்புறம் போவோமா? ஆமால, இந்த கோயிலுக்கு ஆமா நான் ஏதோ வேண்டுதலோட வந்தனே அப்படின்னு ஒரு 10 வருஷம் கழிச்சு யோசிப்போம். எக்ஸாம் முன்னாடி போறோம். ஏன் எக்ஸாம் முன்னாடி போறோம்? பயம். வேற ஓகே, என்ன கிடைக்குது? என்ன கிடைக்குது? we get some confidence. இந்த கேஸ்ல ப்ராபபிலிட்டியில நடக்குமா நடக்காதான்னு தெரியாது இல்ல, எக்ஸாம்ல பாஸ் ஆகுமா பாஸ் பண்ண மாட்டோமான்னு தெரியாது. அஃப்கோர்ஸ் நம்மகிட்ட ஒரு டேட்டாவும் இருக்காது. ஏன்? முன்னாடி பார்க்கறத எழுத முடியாது, பின்னாடி இப்போ இருக்கிறவனையும் பார்த்து எழுத முடியாது. அண்ணா எழுத முடியுமா? எழுத முடியாது. தங்கச்சி எழுத முடியுமா? எழுத முடியாது. அப்பா ப்ரொஃபஸரே இருந்தாலும் எழுத முடியுமா? எழுத முடியாது. அப்ப இங்க என்ன இல்லை நம்மகிட்ட? ஒண்ணுமே இல்லை. ஏன் கடவுள்கிட்ட போறோம்? நல்லா தெரியும் நமக்கு என்னன்னு. 100 தேங்காய் உடைச்சாலும் ஒன்றும் நடக்காதுன்னு. பட் ஸ்டில் வி ஆர் கோயிங். ஏன்? டு கெயின் அ கான்ஃபிடன்ஸ். நடக்குமா? நடக்கலாம். நடக்காம போகுமா? அதுவும் நடக்கலாம். The same thing when you like to use your probability for research, you don't have any data, will be making decision in a scientific way. Without knowing anything, without any data or with the partial data, will be making scientific decisions. Will be making decisions without anything. That's why any R&D requires these kind of people. Okay? So without anything will be making decisions. That's very powerful, right? That's very powerful. Okay? So that's why this random variable plays major role in our research. Right. of course, what I do with this? என்ன ஆமா probability discrete continuous என்ன so what? How I'm going to use it for my research, right? So we'll use few distributions based on the time. I'll restrict. Of course, you all studied this in your undergrad. I'll wind up with the application. Madam, இன்னும் half an hour இருக்கா? எவ்வளவு நேரம் இருக்கு? என்ன மேடம்? Oh, okay. These are the distributions we use in our research, of course, in your ME thesis also with knowing the concept of this or without knowing the application of this. This binomial distribution is a discrete distribution. Once it is discrete, we call by probability mass function. We denote it by P of x. When I use this binomial distribution, where P plus Q equal to 1, n varies from 0, 1, 2, 3, etc. X varies from. That seems to be math? Seems to be math? Can we prove this is not math? I hope you recollect the sense here. What is the sense here? So what we do though with this? N factorial by r factorial into n minus r factorial. Let's say I have 4 persons with me. I have A, B, C, D, 4 persons. I would like to form a committee of minimum 2 members. How many ways I can form a committee? Is it AB, AC, AD, BC, BD? Of course, CD. How much it is? 6? Is it? 6 ways we can form like this. This is the simple way. Let's say we are 60 here. I would like to form a group at the end of this session, end of the day, to give some certificates. Okay, let's say 4, right? 4 persons with us, with the combination of minimum 2. Is it 4C2? See that 4 factorial by 2 factorial into 2 factorial. Is it 6? 4 factorial is 1, 2, 3, 4, and of course 2 factorial is 1 into 2, and here 1 into 2 will be get 6. We'll get 6. That's this. How many ways I can choose a data? How many possibilities are there? How many possibilities are there? Can we make like this? Can you, out of this 60, I would like to form a group of 4 members. How many ways it's possible? Can you make 1, 2, 3, 4, 1, 2, 3, 5, 1, 2, 3, 6? Can you do manually? It's very tough. It is made very simple here. 60C4. It's simple. 60 factorial by 4 factorial into 56 factorial. How much it is? Okay, see that it is 60 into 59 into 58 into 57 into 56 factorial divided by 4 factorial into 56 factorial. So how much it is? Multiply பண்ணி பாருங்க. How much it is? கையில் எப்பவுமே ஒன்று இருக்குமே, அதை வச்சு செக் பண்ணுங்க. How much it is? Of course, this is 1 into 2 into 1 into 2 into 3 into 4. This is 15. This is 15, and this is 5. Tell me, 59 into 58 into 57 into 5. What is that? How many ways? போட முடியுதா? அட்லீஸ்ட் மொபைலில் எப்பயாவது ஒரு வயசாக யூஸ் பண்ணி பார்க்கலாமே. 59 into 58 into 57 into 5. 48? 48? 7635. See, with the 60 itself, we can make such combination. That much powerful is this. That much powerful is this. Within the 60, we can make 4 lakh 87. Is it 4 lakh or 48,000? Check. Okay, right. So, what is the use of this? Let's say, I'm a quality inspector. I'm in a position to accept the goods or to reject the goods. To accept the goods or reject the goods. I have two constraints. Any one of these constraints. If I test the product will become faulty. If I test the product will become faulty. That product will become defective. Or I don't have enough manpower to test the product. Can you say a product, when we test it will become faulty? Any product, when we test it will become faulty? Can you say some product? நான் சொன்னேன்னா அவ்வளோதானா அப்படின்வீங்க. ஃபுட் முறுக்கு இல்லை, என்ன வாங்கலாம்? உடச்சு பார்த்து கடையில். நல்ல எக்ஸாம்பிள். எல்லா முறுக்கும் உடச்சு பார்க்க முடியுமா? உடச்சிட்டு வீட்டுக்கு எடுத்து போனால் என்ன ஆகும்? அப்படியே ஒரு அம்மா உட்காந்துருக்கோம் எலக்ட்ரிக்கல் முடிச்சுட்டு. முறுக்கு வாங்க தெரியல, நீ என்ன ப்ரொஃபஸராக இருக்க? Okay, so it will become a faulty item. Let's say when we are going to get a bulb from the shop, what we do? Check பண்ணி பாம்பு எரியுதான்னு. கீழே போட்டால் உடையதான் செக் பண்ணலாமா? கடைக்காரன் என்ன பண்ணுவான்? கையை உடைச்சிடுவான். So we cannot test the item in this case. Or let's say I have a consignment of bolt 50,000. Can I test each product? Can I test? Lack of manpower. Test பண்ண முடியாது. Suppose I test, what will happen to that product? Hardness இருக்கா? எப்படி செக் பண்ணுவீங்க hardness? Thickness பார்க்கலாம், weight பார்க்கலாம், thread கரெக்டாக இருக்கா பார்க்கலாம். Hardness எப்படி செக் பண்ணுறது? உடச்சு பார்க்கணும். உடச்சா என்ன ஆகும்? The product will be defective. See that's powerful here. Let's say I'm in a position to accept the goods or to reject the goods. I have 1,000 products with me. 1,000 products with me. 1,000 items with me. Okay. So I'll test based on the requirement. Let's say I have taken 10 products, out of which 3 are defective. Of course, we read success plus failure equal to 1. Venn diagram, right? Success plus failure equal to 1. Defective plus non-defective equal to 1. So what is this? Remaining. Okay. And 1,000 minus 10. So I'll get my probability easily. I can decide to accept or to reject. We don't have any other choice. If we test, product will be defective. Or lack of manpower. It is unnecessary also, testing all individual bolt. So I can make a conclusion to accept the consignment or not. That's what I told you. It's like a scientific decision making, like going to the God. We need to have a meaningful conclusion in a scientific way. சும்மா பார்த்தோன்னே வாங்கிடலாம், மேலே போய் ஒத்துப்பாங்களா? வாங்கலாம். 2-3 தடவை வாங்கிட்டு அப்புறம் என்ன பண்ணுவோம்? ஸ்டாட்டிஸ்டிக்ஸ். இவன்ட்டா சரியில்லை, அதுக்குள்ள காரில் இருக்க 4 கார் டயரை கழட்டிட்டு போயிருக்கு ரோட்ல. What's the use? That's why the testing is done in the roads. Okay, so let's say next, Poisson. Kindly use Poisson. The word is Poisson, not Poisson. It's Poisson, right? It's a French mathematician. Poisson. So discrete PMF, right? Lambda greater than lambda 1, 2, 3, x equal to 0, 1, 2, 3. See, this Poisson is, In the case of binomial, I would like to know defective as well as non-defective. In the case of Poisson, I would like to know either defective or non-defective. Can you say some example which is, I would like to know only defective. Any example? Defective. Number of accidents in a road. Is it? Why we bother about non-accident cases? Of course, as a teacher, we bother about whom? We bother about whom as a teacher? Number of students failed. Number of students failed. நம்ம present பண்ணும்போது மேனேஜ்மென்ட்க்கு என்ன present பண்ணுவோம்? See, these many students are passed அப்படினும். மேனேஜ்மென்ட் என்ன சொல்லும்? See, these many students are failed. Okay, so I bother about either success or failure. Number of accidents in a road. See, maybe at the end of the session, the coordinator will see how many participants are not turned up today. Why they bother about turned up cases? We never bothered about turned up cases. Number of accidents in a road. Okay, so number of accidents in a road. Number of machine failures. When we know number of machine failures, then only this many inventories are required. We bother about. Okay, so it's Poisson. Here we bother about success as well as failure. Here we bother about success or failure. It depends. Okay, next geometric. Again, this. Sorry, I'm unable to discuss much applications. I'll restrict with few. Yeah, geometric. I bother about first success or first failure. Give me example. First success or first failure. In your topic also you have your first success. A lot of examples in real life. First success. I'll stop the process one day once I get the first success. Or my intention is up to first failure, I'll stop. Any example? புரியாத மாதிரி பேசுறேனா இல்ல புரிஞ்சிக்கூட ட்ரை பண்றீங்களா? I'm conducting an experiment. I'll stop the process if my intention is first success. If the same process, my intention is first failure. Any example? Okay. ஸ்கூல்ல இந்த பியூரெட்லாம் வச்சு வாத்தியாரே என்ன பண்ணுவோம்? ப்ளூ கலர் வந்தோடனே ஸ்டாப் பண்ணுறோம். Is it? It's simple geometry. ரொம்ப சிம்பிள். எத்தனை தடவை எக்ஸாம் எழுதுவோம்? ஆமாம், பாஸ் பண்ணால் அதுக்கப்புறம் வாத்தியாரே மறந்துடுவாங்க. சிம்பிள். தட்ஸ் ஜியோமெட்ரிக் டிஸ்ட்ரிபியூஷன். அஃப்கோர்ஸ் ரெக்கார்ட் ஆகலைன்னா பொண்ணு பார்க்க போகிறோம். எத்தனை தடவை? கிடைக்கிற வரலாம். தட்ஸ் ஜியோமெட்ரிக் டிஸ்ட்ரிபியூஷன். அஃப்கோர்ஸ் ஆஸ் எ பேச்சுலர் ஹி நோஸ். That's geometric. See, you can see an advertisement. Recently, also I saw one very big manufacturing company. Few students, they'll come in, automatically the light glows. When the kids are going out, light off ஆயிடும். கவனிச்சிருப்பீங்க. Our switches are works up to 600 clicks அப்படிங்கிறாங்க. With it 600 clicks வரலும் ஒர்க் ஆகும். வாரண்டி என்ன கொடுக்குறாங்க? Up to 600 clicks அப்படிங்கிறாங்க. Whether they checked all the products? No. If they check the product, it will become a faulty. So they will take few samples. They do with the samples. First failure எதை வச்சு வருதோ அதை வச்சு தான் they will be giving. Any warranty guarantee is given based on this. They don't test all the products. They take few products and they test with that. They will take a call, meaningful conclusion. Geometric. Okay. So see here. We bother about success as well as failure here. Faulty, non-faulty, defective, non-defective. And we bother about here success or failure. Number of accidents in a road, number of machine failures, number of students failed, number of employees not turned up for a day. And here first success or first failure, warranty, guarantee and all this. See, we are expecting some desired product. Up to that, we will be doing that experiment. That's it. When we get a meaningful conclusion, we'll stop that. That is geometric. Yes, uniform is continuous. Can we define like this? Continuous PDF, and it is denoted as f of x. Okay. 5 minutes. Okay. So, is it simply 1 by b minus a, 0 otherwise? We said 30 to 60 kilometer speed I traveled. What is the 0 otherwise? What is the 0 otherwise? Whether we are always traveling 30, sometimes we are stopping in the signal, that's negligible. We are not taking into consideration. If you start any machine, we don't bother about the efficiency of the machine. That's what mileage, they call it as ARAI conditions, right? You travel between 40 km speed lapo, appo evlo mileage, that's what. Because first gear, second gear la varadu. You reach the top gear, travel in a particular speed, that's it. So 0 otherwise. Okay, 0 otherwise. So 30 to 60, A less than B, less than X, less than B. And exponential similarly like that. This one mostly electrical and electronics, computer science people they use. Exponential distribution. Example நீங்க தான் சொல்றீங்க. Upper limit தெரியாது. Any example? I know the lower limit. Upper limit தெரியாது. எப்போ நடக்கும் எப்போ வேணாலும் நடக்கலாம், random variable. Any example for the thing which we don't know the upper limit? Huh? Okay, death. Can you say I live up to 80, 70, 90? How about the owner of this LED projector, LED panel? Can you say this panel will work for next 2 years? Can you say? Next 1 year? Can you? How about your mobile? Recently I bought iPhone 15, I'll keep it for 2 more years. Can you say that? அப்படி காதில் ஸ்கூட்டியில் வச்சுருப்போனா வேலை முடிஞ்சு, வேலை முடிஞ்சு, அதோட கதையும் முடிஞ்சிடும். So, as she said, life is a upper limit தெரியாது. Any equipment, either it is bulb or machinery or bike or car, it falls under exponential distribution. We don't know the upper limit. சில ப்ராடக்ட் 10 வருஷம் கூட வச்சிருப்போம், சில ப்ராடக்ட் 10 மாசத்துல போயிடும். Got it? We don't know the upper limit. Anything, right? So இந்த பென் எவ்வளோ நாள் எழுதும், இந்த இவர் முடிச்சிட்டாரு அடுத்த கிளாஸ் வச்சுக்கலாம். Nothing like that. That's why we call as hazard rate. Hazard rate. That's why we call as accident. Accident. Okay, exponential. We don't know the upper limit. It may happen any time. It may happen at any time. Okay, so again normal distribution, of course school la irundhu padichadu netik saaram sollirparu 2 sigma square, this is okay, normal distribution. See, these cases we know the individual data, number of accidents, number of defective, non-defective, how much I travel, I know the upper limit, lower limit, I don't know the upper limit. In this case of normal distribution, we know only mean and average. That's why most of the time we are using in our research normal distribution. On an average, these many accidents are happened. On an average, these many machine failures are happened. This many product has turned up in a good way. So we know mean and average. This many accidents in a road and on average. This normal distribution is an approximate distribution to all the distributions. Statistics particularly we use only normal distribution because we know only the mean and average, standard deviation. When we know the approximate value, we have to use this normal. If you would like to use binomial distribution, of course you can use this. When you would like to use Poisson distribution, of course you can use this normal distribution. But it gives you only approximate value. If your research is particular domain on specific on particular thing, you have to use the particular distribution. Of course, you can use this, but you would like to use uniform? Yes, of course, you can use this normal. But it is only an approximation. Right? So, I conclude, though it seems to be like math, we have software, of course, next session you have MATLAB. It's very powerful software. Of course, I'm using most of the time my SPSS or MATLAB for my research. And these are inbuilt there, but the software will not tell us which distribution you have to use. That's why we should be very cautious on these topics. The distribution will not tell us whether it is discrete, no. Whether it is continuous, no. Even the software will give you probability of this is 2.35. The software will give us a result like this because our data, the whatever we have given input is wrong. The software will not tell us this is wrong. So what is our role? We have software for everything, we have software, but our role is which distribution, whether I would like to know success as well as failure, whether I would like to know only success or failure, or mine is continuous, it's in between something. No, I have only lower limit, I don't know upper limit. So this we have to decide. Otherwise, we have powerful software, and of course, we can write meaningful conclusion based on the result what software gives. Software will not tell us what is the conclusion. We have powerful software, SPSS, R, Minitab, MATLAB. Okay, so what I'm expecting after this from the knowledgeable audience, at least write one math equation like this to get a paper published. If you want to write math expectation, write this. This is enough. If you are using Poisson distribution, better you write it is P of x equal to e power minus lambda, lambda to the power x by x factor. That's more than enough. Okay, if you are able to write one or two equations in between there and in a page, that's more than enough to publish in a IEEE paper. Yeah, of course, due to time limit, I'll stop here. Of course, when we would like to talk about this, minimum 3 more hours are required. So, so that's fine. Yeah, any questions? Any clarifications required? No? But it's no, I'll wind up this. Thank you for your patience.
Thank you, sir.
Thank you.
Thank you for the excellent lecture, and you have related maths with a practical thing. A small,
Thank you, madam.
as a token of love and appreciation from CFR,
Oh,
a small memento, sir.
Thank you, madam. Thank you. I'll do it. Yeah, any clarification? Yeah, of course, you mail here, Arivu at Anna. .edu. Thank you, madam. Thank you. Okay, start leaving. Thank you. Thanks. Yeah, you can mail me here. Of course, I'll respond sometimes. And my area of research is this wireless sensor network. You can search my research papers by, of course, if you have net, you can search now yourself. You can see there are lecture notes also there related to the subject. It's around 60 hours I have given, right? So, of course, when you see these papers are mostly in IEEE and ACM and all, படிச்சு முடிச்சதுக்கு அப்புறம் ஒண்ணும் இல்லைங்களே அப்படினு நினைப்பீங்க. Of course, in between I have written few math equations. I used exponential, that's it, right? Wireless sensor, it has limited energy and life. That's what I did. Okay, very simple. I'm not an engineer. I'm not in good engineering also. So what I know is I have written here. That's why I could publish a paper of with impact factor 6, 9, 10 and all with the basic math behind this. So I'm expecting you all to write in between 2 lines of math. Thank you.
Thank you, sir. Thank you very much.